Hello everyone, we're going to look at our study guide, our review for Module 10 so we can be ready for the test. Here we go. All right, so we have show that the quadrilateral formed is a trapezoid. So first thing I'm going to do is graph those points, -5, -1. That's my A. Then I have 3, 1. That's B. 2, -3. That's my C. And then -2, -4, that's my D. So if I draw that shape, hopefully it's going to look like a trapezoid-ish. There we go. Then you can go through, if we want parallel, first of all, if we want parallel here, that means we need the same slope for one pair of our opposite sides. So looking at the shape, the ones that look parallel to me are going to be my AB and my DC or CD. However, you may go through and find all the slopes if you want, just to prove it. So I'm hoping that when I find these slopes, they end up being the same. So if I go to A to B and count, I'm going up 2 and across. So I'll write that down, up 2. It's my rise. And then run 1, 2, 3, 4, 5, 6, 7, 8. When I reduce that, I get 1/4. So I'm hoping DC ends up being the same thing. If I start at D, I go up 1. And then I run 1, 2, 3, 4. Looks like they match. So I can say AB is parallel to DC. And then my conclusion would be, not to go back to the beginning, sorry about that. There we go. My conclusion would be A, B, C, D is a quadrilateral. Not a quadrilateral. I'm sorry. I don't know what I'm saying there. Just kidding. Is a trapezoid. That's what we're proving. We already know it's a quadrilateral. Is a trapezoid since it has one pair of opposite sides that are parallel. There you go. All right, let's try the next one. Sorry, just in case you didn't see that one more time. ABCD is a trapezoid since it has one pair of opposite sides that are parallel. Okay, number 2. Show that the quadrilateral formed by EFGH is a rectangle. So again, I'm going to start by graphing it. E is at -5, 3. F is at -4, 5. Then we have 4, 1, and 3, -1. All right, so I'm going to connect those dots. When I didn't label them, let's go back and label them. So that was E, F, G, and H. All right, this one, our hint is that consecutive sides must be perpendicular. For perpendicular, that is when we need to see negative reciprocal slopes. Negative reciprocal slopes. So that's important that we actually have negative reciprocal slopes. Sorry about that. Let me just write this word reciprocal a little bit neater for those who are trying to read that later. They won't make much sense of that scratched up word. Let me try that again. Reciprocal. All right. Negative reciprocal slopes. Here we go. I'm going to test every single side because all the sides, consecutive meaning one side after the other. So each side that I go around and look at has to be perpendicular to the last. So I'm going to start with EF. And this is looking at the slope for EF. Okay, so the slope for EF. Having a hard time writing today. There we go. The slope for EF. And again, I'm going to count it. So I'm going to go up 2 over 1. So rise 2, run 1. Then I move on to the slope for FG. And from F, to get to G, I like to do my rise and run first. So I'm going to do that first. Down 1, 2, 3, 4. Okay. So that's down 4 and then run 1, 2, 3, 4, 5, 6, 7, 8. Run 8. Then I can reduce that to -1/2. And if I compare those two, EF and FG, they are reciprocals. One positive, this guy's positive, this guy's negative. So those two are in fact perpendicular. So I can say EF is perpendicular to FG. Okay, then I continue, not backwards, sorry, forwards. So then I do the slope of GH. So to get from G to H, I go down 2. So -2, and then I go back 1, -1, which gives me positive, negative divided by negative, I have positive 2, or you could say 2/1. That helps you to see your fraction. Sorry about that. A little bit better. Then if I compare those two, again, one positive, one negative, and they are reciprocals. So FG is perpendicular to GH. Then we go on to the next one, the slope of HE. And to get from H to E, this one, I'm going to go up 1, 2, 3, 4, looks like, up 4. And then I'm going back 1, 2, 3, 4, 5, 6, 7, 8. I go backwards 8. And that gives me, sorry about that, a reduced 1/2. That's negative. Then if I compare the last two, GH and HE, once again, reciprocals, one positive, one negative. So I can say GH is perpendicular to HE. My final step here would be I only have 3 sets of perpendicular lines and I need all 4. So I need to go back to the first one and compare the slope of EF and HE. So if I compare those two, their slopes, I have one positive, one negative. So here's the first one up there was positive. The one on the bottom is negative. That's this guy and this guy, positive and negative. Okay. And so then I can say EF is perpendicular, not only positive, negative, but also again, reciprocals. So that is how we can say that they are perpendicular. And I keep switching slides on you. Sorry about that. Let me just erase these circles real quick. And then we're set to go. We're ready for our conclusion. We have all the sides are perpendicular, which means all right angles and a rectangle. So here we go. We would say EFGH is a rectangle since all, and we can use that fancy word, consecutive, meaning one side after the other. All consecutive sides are perpendicular. What happened there? Something weird. Perpendicular. And again, the point of this, when we say perpendicular, is that they form right angles. And that would be they form all right angles. I'm going to sneak that word in, all. Although I have not required you to say both. If you say perpendicular, that's good enough for me. But I am going to mention this, that's what we're going for. Form all right angles. All right. Then we're on to number 3. Show that the quadrilateral JKLM is a parallelogram by showing, and this one says specifically by showing both sets of opposite sides are congruent. If we are looking at congruent, we are looking for same length, or as we do it on a coordinate graph, that would be the same distance. So this is a distance formula question, a whole bunch of distance formula. I'm going to do distance formula 4 times to do this question. Okay, come back. There we go, distance. Okay, so I'm going to start by graphing it, of course. I have -2, 3. There's my J. I have 1, 2. There's K. I have -2, -3. There's L. And -5. 1, 2, 3, 4, 5. And -2. And there's M. So if I connect those, oopsie, I'm not sure what happened there. Try that one more time. Okay, so connect those. Lovely. All right, so we're supposed to show opposite sides are congruent. So I might actually start with my opposite sides. It's kind of up to you. You could just work your way around. I think I actually will work my way around because I like to have my letters work out that way. So I'm going to call J order pair 1, K order pair 2. Come on, 2. And here we go with my distance formula from J to K. I'm going to set up this loveliness. I have x2 minus x1 is going to be 1 minus -2 n squared, plus y2 minus y1, that's going to be 2 minus 3 n squared. And then I simplify. Here, I'm going to erase this so I can have a little bit more space here. Sorry about that. Didn't need as much space as I planned for. That's awesome. Okay. Equals, and then I simplify. Remember, minus a negative means plus, so that's 1 plus 2 is 3. And then 2 minus -3 is -1. And when I square that up, I get square root of 10. All right, so then I'm going to move on to KL. Set up my nice big distance formula. And K is already marked as order pair 2, so I'm going to call L order pair 1. So here we go. I would do x2 minus x1. So that's 1 minus -2. That's funny. And then we have 2 minus -3. All right. I missed a parenthesis in there. Okay, so that was 2 minus -3. All right, so this one, 1 minus -2, we actually just did that math. That was 3. 1 plus 2 is 3. And then we have 2 minus -3, so that's going to be plus, so we'll end up with 5 squared. And when I do that, I believe that gets us square root of 34. So that will be 9 plus 25. Then on to the next one, LM. So for this one, LM, now that we've done a couple sides, this LM we're hoping matches up with JK. So if we do all this right, and it actually is a parallelogram, we should get the same answer we had for JK. So as I look at M, I'm going to call that, let's see, L is already 1, so M is going to be my 2's. Why won't it circle it? I don't know. There we go. All right, so x2 minus x1. So I'm going to have -5 minus -2, excuse me. Okay, then for the y's, -2 minus -3. Something funny going on there again with my pen here, sorry. Okay. And then if I simplify, then I'm going to go through and remember again, minus a negative means plus. So -5 plus 2 is going to give me -3. -2 plus 3 is going to give me, excuse me, there's -1. Try to write that one more time. So plus -1 and squared. And then our final result there is, what do you know, lo and behold, square root of 10. All right, then the last one we need is J to M. And since those are, yes, they are marked correctly with our numbers, 2's and 1's. So here we go. X2 minus X1 is going to give me -5 minus -2 and square it, plus -2 minus 3 and square it. And then I'm going to simplify. So again, minus a negative is plus. -5 plus 2 is -3. And then -2 minus 3 is going to give me -5. And if I simplify, I get 9 plus 25, again, square root 34. So you can see those matching slopes. All right, so then my final result here. Before I do my final result, I see the matching slopes. I'm sorry, not slopes. Excuse me, not slopes. I see the matching distances or lengths. So those are the lengths of our sides. Excuse me for that little error. Okay, so I would say, the right one here, that JK, side JK, let me write that a little nicer. Side JK is congruent to side LM, and side KL is congruent to side JM. So that's an important step. Yes, we can see the numbers match, but you're actually telling me you understand the geometry, that the numbers match, which means the sides are congruent or the same length, distance. Okay, final statement. We would say JKLM is a parallelogram since both pairs, and change the slide, of course, of opposite sides are both pairs of opposite sides are congruent. And I'm really tired of it flipping to a different slide. There we go. So JKLM is a parallelogram since both pairs of opposite sides are congruent. I'm just going to write this K a little bit neater. And I think that's it for that one. Then to finish this off, let's go to our last one, number 4. Araceli is trying to prove that quadrilateral ABCD is a parallelogram by showing that both pairs of opposite sides are parallel. Notice this time we are looking for opposite sides are parallel. And parallel, of course, meaning same slope. She has calculated all the side lengths and slopes as shown below. Is she able to prove it? If yes, give her conclusion statement. If no, then explain why not. So the key here especially is the part that I underlined. We want opposite sides to be parallel. So opposite sides is going to be every other one, AB and CD. So either this one with this one, or that's one set of opposite sides. Then the other set would be BC and AD. So we're matching up every other one, so to speak. All right, so if I look at my opposite sides, since I want parallel, I actually don't even care about the length for this particular question because all I'm focused on is slope. I want same slopes. So if I compare my first one, AB and CD, do they have the same slope? Yes, they do. Good to go. Then I compare the other ones, BC and AD, and those also have the same slope. They match. So then I am able to say, is she able to prove it? Yes, she can prove it. And it says, if yes, give her conclusion statement. And so we say, yes, she can prove it. Here's our conclusion, that A, B, C, D is a quadrilateral, not a quadrilateral, I like to say that apparently, is a parallelogram. Since both pairs of opposite sides are parallel, but here it's important. We didn't actually say in any of our answer, I circled, but we didn't actually state that the slopes were congruent or equal, same. We need to say the slopes are the same somewhere, so I'm going to add that in my statement here since both pairs of opposite sides, are parallel. Since both pairs of opposite sides are parallel, because they have the same slopes. Okay, and that's kind of a run-on sentence in English, but we're going to live with it. And apparently change slides again. Gotta love that. Get back there in just a second. There we go. All right, so I would ask, are there any questions? But you can't really ask a video. So there you go. Good luck on the test tomorrow. We'll see you later.